Okay, for objective of this experiment is to determine the drop time for various weight of the flywheel apparatus through experiment and compare to the value using the theoretical equation.
The apparatus that we use in this experiment is flywheel apparatus, weight hanger, weight, a marker, measuring tape, and lastly stopwatch. Mark the reference line at the end of the curve. The reference line will be used in the recording the number of turn of axis and action.
Consider this as a flywheel and this as a load, and then we tie it with a thread together. This okay. Thank you.
These are the dimension that we get from the experiment for axial and flywheel. Also, they are the number of turn of string on the action. The drop time taken for each mass from rest to minimum point. And the second one table is for angular acceleration by using this formula, and for linear acceleration we use this formula. And lastly, to find a moment we use this formula. For the third table, or the value for moment for experimental and theoretical. For the theoretical value, I use this formula. In the procedure, we need to plot a graph. They ask us to plot a graph, so this is the graph for moment versus angular acceleration. From the graph, we also need to find a slope. So they are the value for the slope. Discussion 1. Draw the free body diagram and a kinetic diagram for the flywheel and weight. Here is the free body diagram and kinetic diagram for flywheel and weight. Discussion 2. Compare and discuss the result of the drop time and moment of inertia for various weight of the flywheel apparatus using the theoretical equation and compare to the measurement in the experiment. So for the first weight, 0.4 kg, it takes 50.666 seconds, and it is the longest one to complete the rotation, and the value for the moment of the inertia has the lowest one. And the last weight is 2.0 kilogram. It is only take 7.03 seconds for the weight to complete the rotation, while the value for the moment of the inertia is the highest one in the data. From the result, we can see that the more weight we put on the weight hanger, the time take the weight to complete the rotation is decreasing, while the moment of inertia is increasing when the time is decreasing. Same goes to the experimental value. Discussion 3. Give your comment or suggest at least 4 causes of error that may affect the result of the experiment. Okay, the first one is human error. This experiment is being handled by a human instead of machine. Second one is miscalculation and inaccurate when counting the number of rotation. The third one, error in recording the time taken for the number of complete revolution. Last one, energy loss because of the friction between the flywheel core and the cord.
For discussion 1, I will show the free body diagram and kinetic diagram for the flywheel and its weight. For discussion 2, we need to compare and discuss the results of the drop time and moment of inertia for various weights. From the table, it can be said that when time decreasing, the moment of inertia will increasing. For example, when a load of 0.4 kg, we can see that it has the highest drop time value. Meanwhile, it has the lowest moment of inertia. Whereas for the highest load for 2 kg, it has the lowest drop time value but the highest moment of inertia. It can be concluded that as a load increasing, the time will decreasing and the moment of inertia will increasing. Alright, the last one is there are 4 types of error that may be affected in this experiment. The first one is human error. The experiment was handled by human measurement instead of machines. Second one is error in procedure. There are 3 examples, which is miscalculated number of rotations, wheel rotates at high angular velocity, and the last one is error while recording the time taken. Third is systematic error. This error happens when using a poorly calibrated instrument to measure the circumference of the disc and axle. And the last one is parallax error. This error occurs when the pointer on the measuring tape is not observed along a normal line to a scale.
For the discussion, the first question is draw the free body diagram and kinetic diagram for flywheel and weight. The second question, compare and discuss the result of the drop time and moment of inertia for various weight of the flywheel apparatus using theoretical equation and compare to the measurement in the experiment. The answer is the result is different. It is because the moment calculated using theoretical equation is included with error that make the result different from the experimental result. The third question is give your comment or suggest at least 4 causes of errors that may affect the result of the experiment. The answer is 4 causes of errors that may affect the result of the experiments is systematic error, parallax error, instrumental error, and human error. Parallax error is an error which is the error when taking any measurement when the eyes are not parallel with the uh, instrumental measurement. Thank you.
Question number 2. Compare and discuss the result of the drop time and moment of inertia for the various weight of the flywheel apparatus using theoretical equation and compare to the measurement in the experiment. The drop time taken for the load to reach the minimum point is gradually decreased from the longest time taken for load 0.4 kg, then decrease at load 0.8 kg and follow with 1.2 kg, 1.6 kg, 2.0 kg. The moment of inertia that is calculated using the theoretical equation is larger compared to the experimental result even with different weight. This is because in the moment calculated using theoretical equation is included with error that makes the result different from the experimental result. Question number 3. Give your comment or suggest at least 4 causes of errors that may affect the result of the experiment. First, systematic error when using the instrument to measure the disc and axle. Second, parallax error, which is the error when taking any measurement. When the eye not be parallel to the measurement, it is because a slight error in the dimension of measurement. Third, instrumental error is the error due to damage or rusted instrument. When the flywheel have a slight damage, it will cause an error. Fourth, human error, which is normal when carrying an experiment that cause the result to be too big or too small.
In conclusion, from the result, we get to achieve the objective where we want to determine the drop time for various weeks of the flywheel apparatus through experiment and compare to the value using the theoretical equation. From the result, we get to see that time taken is decreases when the weight is increased. We also get to verify that the second law of rotational motion, m equal to moment of inertia times angular acceleration, where we see that the moment of inertia increases when angular acceleration is also increased. It means that the moment of inertia is dependent on the angular acceleration. These are my conclusion based on my observation from this flywheel experiment.
My conclusion for this experiment is at the end of the experiment, it can be said that all the objectives were successfully achieved when moment of inertia, frictional moment, and moment of inertia when using theoretical equation can be obtained based on the formula given. The flywheel is made to rotate by attaching a load to a string. From the results, the experimental value of moment of inertia are found to have huge deviation ratio from the theoretical one. When the mass is increased, the moment of inertia also increase. After that, we conclude that error that involved in this experiment is human error. Error in procedure, there are 3 examples of this error. systematic error, and the last one is parallax error.
The conclusion, the objective were achieved during the experiment. At the end of the experiment, we were studied about flywheel and axle. Other than that, we get to compare the value using theoretical equation and value experimental equation. The value are different than experimental because the error occur.
In conclusion, I have achieved all of the objectives at the end of the experiment. I can verify Newton's second law for rotational motion. Then I can determine the moment of inertia of a disc and axle from experiment. I can also determine the frictional moment required to overcome the friction. Next, I can determine the moment of inertia of a disc and axle using theoretical equation. From the experiment, we can know when mass is increased, then moment of inertia also increase.